Everyone, so we are going to do a hands-on lecture dealing with Chapter 9, which is Classes and Objects. And so, since it's hands-on, I'm just going to start a council application. I'll have my solution. We'll just call this Chapter 9 lecture. And the first project, we'll just call it demo. And so this chapter starts out with a lot of theory. I'm going to start then. Let's see if I can zoom in here and kind of change this up so you can see this a little bit better. I'll zoom in and zoom out as I need to. Okay. So everything up until this point, when we've written a C# program, has started this way, where we have one file. And so up until now, everything looks like this. AKA, there's only one file. But C# is an object-oriented programming language, OOP. And that's a term that you need to be familiar with, object-oriented programming. Because it's object-oriented programming, you guys remember the other one? It's not, since it's object, it's not procedural. Procedural was the other paradigm of a programming language. And so object-oriented, any language that's come out in the last, I don't know, 10, 15, 20 years has primarily been object-oriented. And because it's an object-oriented language, we have to learn about objects. And right now, up until this point, everything we've written has, for the most part, been in main, or you started writing your own methods, but it's all inside of one file. And one of the benefits, and we've talked about, object-oriented programming, benefits of OOP is code reusability. Probably had a typo there, but and that's, I always ask, why do we do this? Why is this important, I should say? Why is object-oriented programming important? And that's one of the main reasons is it comes down to code reusability. Also, when you have objects, just like it was with methods, you're taking the repetitive code out, you're putting it in an object, and therefore if you have to troubleshoot those objects, they're smaller chunks of code to troubleshoot, much like a method. You would be able to troubleshoot in smaller chunks of code. So it really comes down to troubleshooting and reusing your code are some of the main benefits of object-oriented programming. So what we're going to have here is we're going to start having multiple files, and these files are going to work together, right? So right now we just have one file. It does all the work. As that one file would continue to grow in size, though, I mean, imagine a real large application with, maybe hundreds of thousands of lines of code. You're not all going to write it in one file. It's going to be chunked up into smaller chunks, into different files. Thus, we get into these objects. And so to add a new class, and this, we're just going to add that second file. We're just going to right-click on our project, add, and right from this add menu, you could see we could add a class. Or if you just want to add a new item, you'll find that there's a class in here. And we're going to name our class person. And so now you can see we're still in the same namespace, meaning we're still in the same project, we're still in the same folder, if you will. But we now have a class called person. And we can mark this class as public. Which is this is our class header. So this defines the class, much like you had method headers. This is a class header. And inside of here, there are really two things that a person has. A person has attributes, and a person has things that they can do, or methods. So at a very basic level, classes have two things that they're a part of. They have attributes and they have methods, things that they can do. So when you think about a person, what attributes do you think about? How could you define a person? Okay, so we might have a string called hair color. I also heard skin color. Okay, integer for age. Okay, so we're defining these attributes that each individual person would have. Now, I'm gonna rename this to fields. Okay, because I think when I say attributes, you all know what I'm talking about. But a field specifically is the C# term that we're going to use that holds that piece of information about the person. So you could use the term attribute, that's fine. An even better description would be an instance field. Why do you think we use that term instance field? Think about a person's age. If you've got 50 people, do they all have the same age? No, they're all unique. So each particular instance of a person has a unique hair color. Each instance of a person has the ability to have a unique age. Now, they might have the same age. It's definitely probable that some people are going to have the same age, right? That just makes sense. But they have the ability that each instance can hold their own piece of information. So right off the top, we're learning about classes. We have a class header. That's how you define the class. Inside of a class, you've got fields. Now, these are nothing but variables, right? You guys have been working with variables this whole time. But now, these are a specific type of variable, right? Kind of like local variables. We learned about local variables were variables inside of a method. You know, that was a type of variable. And a field is also a type of variable. Now, one thing that is very common, and this is important, so pay attention to this. Your fields, most of the times, should be marked as private. And this is referred to as data hiding. Okay? Meaning outside of this class, this piece of information is hidden. So although we're creating these classes, and these classes are going to work together to create a program, when we mark this field as private, that means other classes cannot directly access this field to work with it. And there's really only two things you can do with this field. You can put data into it, and you can read data out of it. Okay? So when you mark it as private, to put data into it, we're going to have to use a method. To read data out of it, we're going to have to use a method. Okay? So let's go ahead and mark all of our fields as private, realizing this is important to hide your data. Okay? That's an object-oriented programming principle, data hiding. You hide your data, and we talked about this before in previous lectures. It makes it secure, right? It makes the age more secure when other classes cannot intentionally or unintentionally modify this piece of information. Instead, we have a controlled way of working with this. And I'll get into that when we talk about methods. Okay, but I kind of want to go back a little bit, make sure I'm not missing anything. So right now, our classes, there's really two categories of classes, because no, we have class person here now, but there's another category. In this case, we have a class called program, and it runs our application. You all know the main method is where the program starts. Okay, so if we're going back and talking about types of classes, there are two of them. One's with the main method and one's without the main method. Okay, and the reason I bring that up, your programs are always going to start, they have to start somewhere. There's only one start, so there's going to be one class with a main method in it, and then all the other classes are going to be used by that. Okay, so the one class with the main method, that's where your program's going to start. The ones with the main method, I call them, and they're used, they're called, not just by me, the driver. Okay, so classes with the main method, I call them the driver, or they're also known as the class user. They use other classes. The classes without the main method, like person doesn't have the main method in it. This is a class client, meaning its whole purpose is to be used by your program. You know, it doesn't have the main method, therefore, you know, it doesn't start here. Okay, so we have class clients and we have class users. Classes that use other classes, and you have classes that are used by other classes. Okay, so those are the two types of classes. I guess I can give you a demonstration at this point of how to use this class. Okay, so much like a method, you have to define a class first. Like in a method, you have to say, okay, create the method, and then you call the method. So it's always, I always say it's two parts, right? You create the method, then you call the method. In a class, it's the same thing. You have to create the class first, and then you call the class, but it's not given that terminology. And when we're talking about calling a class, and we're going to call the class inside of main, when we use the class, it's called creating an instance. Okay, so we're gonna finish coding our person class, and then we're going to create an instance of our person. Make sure my recorder's going. Okay, my recorder's still going. Good. So again, we have to finish creating our class. We'll write some methods. So what are these called? These are called our instance fields. This is the data about a person. And when it comes to the methods, there are two types of methods that work with instance fields. Okay? Now earlier I said this, I'm going to repeat myself here. These fields are private for the purpose of security, for the principle of data hiding. And I said up top that's important. Okay? Well, down here, because we're just going to pick age, is marked as private, if our main method is going to they're going to be able to modify someone's age. If they're going to be able to modify this age field, you have to create a public method to modify this data. Okay? Again, people, listen, it's very important. Private fields are modified by public methods. I'm going to write it right here. Private fields are modified by public methods. How do you think if you change this variable, if you change age with a public method, how do you think you then retrieve data out of age? Same thing with a public method. Okay? Now this is like the first thing you learn to do with classes and objects is you learn to create instance fields, right? Now, and before it was simple, right? Before we would just say age equals 23. And now we've put a piece of information into age. This isn't working because we have to do this inside of a method. But it was very simple before because our variables were in the same file, you know. But now we need to modify someone's age over here in this other file. And in order to modify someone's age, once we create an instance of a person, we need to modify their age. We're going to do that through a public method. So here's I said up top, two types of methods that work with instance fields, and the private fields are modified. So here's the first type. First type is known as a mutator. Okay, and I'm just going to kind of put that underneath for my notes. So two types of methods that work with instance fields. The first type is known as a mutator. And in here I just write that again, private fields are modified by public methods. So I'm going to write a mutator right here. This is a mutator. So we said it has to be public. And this is a method, and you guys know how to work with methods, right? And it's non-static. It's a non-static method, so we're not using the keyword static. All we're doing with this method is changing this variable age. So it's not going to return any data. So its return type is void. And because it's a mutator, the convention we're going to follow is we're going to call this set, because we're modifying someone's age. We're setting someone's age. So here's a method, public, void, and we're setting someone's age. Now because we can set someone's age to 10 or 50 or 100, we have to accept one parameter in here. And so since age is an integer, I'm going to accept an integer parameter, and I'm just going to call this A for now. But A is going to be the parameter that holds someone's age. And then what we do in here is we set the age field, set the field equal to the parameter. Okay? So what's the field name? The field's name is age, and then the parameter is A. Okay? So this is a mutator. And this is going to allow us to modify someone's age. But here's what you have to realize. How is this any more secure? So over here we're using set age. How is this any more secure than just directly accessing this variable age? You know, over here, if we set this field to public, then essentially over here we could directly access that field and say that person's age is 500. Okay? Well, no one's 500. No one's ever lived to be 500. So, you know, modern science isn't close to getting someone to live to 500. So that's that could be a problem for our program. We might want to not let someone enter a crazy age. And an age, maybe not that all that important of information, but what about someone's salary? What about someone's, um, you know, taxable income? What about someone's, there is information out there that needs to be secure. So all of our fields we're going to mark as private for security. And if we don't need extra logic, then that's fine. But let's say for our program, let's do this. Just as an example of why is this more secure. Check this out. I might say if age is greater than, and I don't know what people can live to. If age is greater than 150, console.writeLine, bad data, log an error. You know what? Or I'll just say bad data. Okay? I'll just say bad data. Let me scroll back over here. And then I'm going to put a comment in here to log an error. So I might put some sort of error in our application letting us know that someone tried to set an invalid age. Otherwise, and I know there are other ranges that you can't be less than 0. Okay? So here is the benefit. When you have a private field and you modify it with a public method, you can set rules on your data based on what they call, business rules. And business rules are, how much can someone get paid? How little can someone get paid? How old can someone be? What are the acceptable, hair colors in our other example? Okay? So here I'm just going to keep it like this. This is a method called a mutator. You see ultimately what this does. The mutator sets the field equal to the parameter. And it might do a little bit of, this is data validation is what this is. You're making sure you've got valid data. So that's our mutator. I'm going to take this comment here and put it right next to here. Okay? So I said that there were 2 types of methods that work with instance fields. One is a mutator. Let's write a second type. Second type is called an accessor. So if a mutator modifies the data, what does an accessor do? It gets the data. Gets the data. All right? What's our data type on this going to be? Not our data type, our access modifiers. They're going to be public, private, protected, internal what? Our methods are going to be public. What data type will this method return? If we're working with someone's age, it's going to return an int. If our mutator is called setAge, what do you think our accessor might be called? GetAge. Now, since all we're doing is getting a piece of information, we don't need parameters on this one. So as I was learning this for the first time, there's a convention here. Our mutators have parameters, but no return type, because all they're doing is they're changing our fields. So they're changing our fields equal to the data that's passed in. The getAge, they return data. So the accessor returns data, but they do not have parameters. So in here, we are going to return the field. So we're going to have the keyword return, and then what's our field called? Age. Okay? So now we have a class called person, and from this class we could create 1,000 people. We could create an array of 1,000 people. Okay, we could create 2 people, 10 people, whatever. The point is we can reuse this person class. Each person has some information that they can store about them uniquely in an instance field. And then because these are marked as private for security, we modify them securely. We modify them securely through the mutators, and we access them securely through the accessors. So let's use it now. We have created our first class marked as public, which, by the way, classes are typically public. Fields are typically private. Okay, so again, just going through what's common here. Classes are public, fields are private, methods are public, typically, when you're working with these. So here is how to create an instance. We've created our person class. It's in the same namespace as our main method. So let's go ahead and create this. This is the syntax to create a person object. And I'm going to put the word behind create. I'm going to say instantiate. Okay? Or create an instance of. So when you create a person or you instantiate a person, this is the syntax. That's what it's called. You're instantiating an object. You start off with the class name. Notice how it's recognized. You start out with the class name, and then you give your variable a name. Whatever you want to call your person. I'm just going to call this person P1. Okay? Just like any other variable. Look at our data type. Everyone look at this right here. Look at our data type. This is just a variable called P1. Its data type is person. Okay? So just get familiar with your data type and your variable name. But then to instantiate an object, you say equals new person. That is the syntax for instantiating an object. So you create a class. From that class, you instantiate an object. The terminology they say a class is a blueprint for an object, or I should say of an object. So you have to create the blueprint before you create an instance of it. I mean, I always think of blueprints, of course, in construction, right? Why do they create blueprints in construction? So that they have a plan for what they're going to build. Why do they create classes? So they can have a plan for what you're going to build in your software. So that's why a class is your blueprint. And then you use that blueprint to instantiate or build an object. So now we have a person. Their name is P1. I mean, their name isn't P1, but the field, the variable, I should say, the variable is named P1. So how do we set this person's age? P1 dot, look at our methods that we have available to us. Can you guys see up there? Yeah, there we go. P1 dot set age, and that's a method. How old are you, Danny?
19.
P1 dot set age to 19. So before today, we did something like this. We would simply say age equals 19. Okay? That's okay, but before today, I could have said something like age equals 1919. And that would have been accepted, right? Because it's an integer, it's a valid integer. But we didn't really, we didn't have anything controlling access or controlling the acceptable values. Now this would not be accepted because in our mutator, we throw an error if the age is too large. We could do the same thing if the age was too small. But just for simplicity, I'm going to set the age to 19. Now, in a console, so clearly this is input, right? We're putting something into age. This is our mutator. So data's gone in. Now we need to access. How do you think, just looking at this, if that's how you mutate that person, how do you think we access that person? P1 dot get age. So now we've created a class, we've instantiated that class, we've put data into the field, and we've done it securely, and we've accessed data out of that field. Now just to show you the flow here. Matter of fact, let's just run it first, just to show you. It's just going to print out 19. So the get and the set, they all worked. But to show you the flow here, I'm going to put a breakpoint in, and I'm going to start debugging. You notice here the breakpoint is hit. We're inside of the main method. Okay, and I'm going to step into. By the way, you can set breakpoints. I see this mistake commonly. You set breakpoints on executable lines of code, which typically means something with a semicolon after it. I see a lot of times people trying to put breakpoints in, like on comments and things like that. It's not going to work. It has to be on an executable line of code. Okay, let's step into our F11. Now look where it went. Look where the flow of the program went. It went into our person class. It went into our set age method. And I can step into it. You can see, following the yellow brick road there, I guess, is if age is greater than 150, well, age, oh, I see a typo there. That should be A. A holds a value of 19. You guys see that? Age doesn't have a value yet. A is the parameter that has a value. So that should be if A is greater than 150. So we could fix that. But simply to say it's not. Else, this is where the mutator actually happens. This is the work. This is the main job of the mutator. To set the field equal to the parameter. Age equals A. Now you can see age has the value of 19. Once this method ends, watch where it goes. It goes back to our main, down to our write line, and because our write line has to access get age, of course it's going to go back to the class and return the age variable, which holds the value of 19. And when that's done running, because we started it without debugging, you didn't actually see the output. If I did a console read line, you would have saw that. Maybe I'll do a console read line. We'll follow it through one more time, and even better. So I'll follow through one more time, but before I do, watch this. We're going to reuse this person class. We're going to create a second person. We know the syntax now, how to create a person. And I'm going to say P2 dot set age. And our second person is going to be 31 years old. Then I'm going to do a console.writeLine p2.getAge. Now let's put our breakpoint back in here, and I'm going to fix my little typo here. If A is our parameter that we have to check against being greater than 150, not age, because age doesn't have a value until you set it. I'm going to go back here, debug, start debugging. Okay, just watch the flow. Now this time A holds 19. So we set that person's age. Do you see now why they're called instance fields? Each person has a unique age. So that field it's in its own location in RAM, in its own instance. Now we go to p2.setAge. For p2, now you can see in our local window A is 31. If 31 is greater than 150, that's false. So we skip over and we set age equal to A. Then we hop down and we do a read line. Now, since we're doing p1.getAge, you can see the age is 19 for p1. p2.getAge, you can see in this case the age is 31. And then we do a read line just to hold the program up to show you that we have two different ages for two different instances of the class. And then we can kind of hit next on there. It waits for us to hit enter or hit something at the keyboard. Let's finish our program. Program over. Okay, that puts this video at 37 minutes. I think I'm going to stop it here and we'll continue after a break.